555 timer pin details. It is an 8-pin IC, as you know. So this is the pin details of 555 timer. So the features of 555 timer is it can be used to produce accurate and highly stable time delays. As I told, it's mainly because of producing. It is mainly used to produce delays. So to produce delays in a communication system, we are going to use this 555 timer ICs, and it is having two operating modes. One is monostable, other one is astable. So monostable means mono means one, stable means stability. Monostable means only there will be two states. For if you take any signal, there will be two states. Okay, in that one in monostable, since it is telling monostable, it tells that it is stable for one state. It is having only one stable state. Other state is not stable. Astable means it is not stable at all. It will be keep on changing. The states will be keep on changing, toggling. Okay, 555 tone can operate with a voltage ranging from +5 to +18 volt. You can operate 555 timer with +5 volt to +18 volt and can drive the load up to 200 milliamperes. So maximum it can drive up to 200 milliampere. It is compatible with TTL and CMOS logic circuit and has a very high temperature stability. It is having very. It is not going to vary with this temperature range -55 to 120 degrees C. So it is having more stability. So TTL means transistor to transistor logic, and CMOS logic circuit means complementary MOS logic. That is what used widely in the industry. So it is compatible with both TTL as well as CMOS. Coming to the application of 555 timer, it can be used as an oscillator to generate the oscillation, linear ramp generator to generate the ramps, to generate the PWM waves, P or PPM waves. PWM means pulse width modulation waves. Pulse width modulation, it's a type of modulation where the width of the pulse will be varied in accordance with the message signal. PPM means pulse position modulation. So pulse position modulation means there to modulate a given carrier signal, they are going to change the position of the pulses. That is PPM. After that, frequency divider. In order to divide the frequencies, we are going to use this, and automatic battery charger. So in battery charges also we can use it. So the basic timing diagram will be like this. So this is the basic working of the 555 timer IC. If you understand this working, you can easily analyze stable, monostable, or any complex circuit. So the basic timing circuit contains a flip-flop, which is SR flip-flop, a set reset flip-flop, and Q bar. So that is our output, and Q bar, that is where we take the output, and Q is connected to the transistor. And we are having a comparator op amp where it is going to compare between the two inputs, and we are having the resistance which is connected here. This is a voltage divider bias kind of resistor we are having, and in the other part we are having a resistor and a capacitor which is connected to the ground. So now we'll analyze how it is going to work. So here reset pin is open because here we are only bothered about the set pin. So reset pin can be given manually. We can reset, we can give reset as one manually. So that's why it is kept open. So here in this case, to find the mathematically, in order to find the voltage across R2, see here we are having 5K, here we are having 10K. So how we found this? By using voltage divider rule, we can find the voltage across this one. So VCC into R2 by R1 plus R2. By using voltage divider rule, we can find the voltage. Now let us see how it works. Here the op amp is the non-inverting terminal is connected to this one, and inverting terminal is connected to this one. We came to know from the voltage divider rule that the voltage across R2 is 10 volt. That means the voltage across this point will also be 10 volts, since the voltage across this will be this minus 0. So obviously the voltage across this will be 10 volt. Now if suppose the voltage across this point voltage across this point is greater compared to this. So what happens to the op amp? The op amp, the non-inverting terminal will be at higher potential compared to the inverting terminal. When positive is greater than negative, automatically what happens? The output will be positive. We know that positive indicates logic 1. So logic 1 means S becomes equal to 1. So during that case, R will be set as 0. So when S is equal to 1, so what happens to SR flip-flop? When S is equal to 1, automatically Q becomes 1 and this Q bar becomes 0. So when Q becomes 1, so what happens when Q output is 1? So automatically this, since it is connected to the base of this transistor, so when logic 1 is given, you know that logic 1 is equivalent to what? Analog equivalent is 5 volt, right? So when 5 volt is given to the base of this transistor, what happens? The transistor will switch on. When the transistor is switch on, since the base is given with 5 volt, automatically the base current will be more. When the base current is more, automatically what happens? The collector current will also be more. Now what happens is the collector current, the collector terminal start driving the current. It start driving the current. So whatever the current we are having here, that will be driven, because initially what has happened is when positive terminal is greater, that means this voltage is greater compared to this voltage, means the current will be flowing like this and the capacitor will be charging. The capacitor will be charging to the peak value. So now when the transistor is switched on, during that time the capacitors, the whatever the charge which is stored in the capacitor, no, that charges will be utilized by this, it will be drawn by this transistor. The collector is going to draw the charges, and since the emitter is grounded, everything is going to the ground. So the capacitor is going to discharge completely and it is going to reach to its zero value. Now in the next case what happens is when this voltage is lesser, when this capacitor is going to zero, then this voltage will be at lower potential. Automatically, this voltage will be at higher potential. Now, when this voltage is at higher potential, what happens? Minus will be greater than plus. When minus is greater than plus, the output will be minus. Output is minus. This indicates the output is 0. So, output is 0 means what? The set becomes 0. When set becomes 0, automatically what we make is we make the reset as 1. When set is 0, what happens to the Q? Q also becomes 0. Q becomes 0 means the analog equivalent of 0 is 0 volt. When 0 volt is given to this base of the transistor, the base, since it is having 0 volt, what happens? The base current will be 0. When the base current is 0, automatically the collector current will also be 0. The collector now, since the base is 0, the transistor will switch off. When the transistor switch off, the current cannot flow through the transistor and it cannot even flow to the ground. So now what happens? The capacitor, uh, again it will start charging, because there is no discharging path now. So what it does, since it is already discharged completely, the capacitor is again starts charging. It will start charging by utilizing the current which is coming here. Now again the capacitor is going to charge to the peak value of this, peak value of this. So when the capacitor charges to the peak value, automatically what happens? You know that the capacitor, once it charges, it stores the voltage and it acts like a fixed supply. Now again, this voltage becomes greater than this voltage. When this voltage becomes greater than this voltage, again what happens? Positive is greater than negative, output becomes positive. When output becomes positive, it becomes logic 1. So S becomes again 1, and during that time R is made as 0 and S is equal to 1, automatically Q also becomes 1, and you know that logic 1 is equal to 5 volts. So 5 volts is given to the base of the transistor. Again the transistor is switching on. When the transistor is switched on, what happens? The collector starts driving the current. So whatever the current which is present here, that means the charges which are present in the capacitor, that will be driven by this transistor. So all the charges will be drawn by this and it is going to reach the ground. So now what happens? Again, the capacitor which was charged to the peak value, that starts discharging and it reaches almost zero, not zero, almost zero. So when again now the capacitor value becomes zero or lesser, the voltage across this point will be lesser. When the voltage across this point is lesser, automatically the voltage across this point will be higher. Now this will be higher compared to this. So now again it becomes minus. When this becomes minus, this becomes zero. When this becomes zero, Q becomes zero. When Q becomes zero, it goes to 0 volt. When it is 0 volt, what happens? The transistor will be off. When transistor is off, what happens? The drawing, the collector which is drawing the charges will stop. When the drawing the collector which is what was drawing the current stops, automatically what happens? The capacitor again starts charging. It again charges to the peak value. Again, this voltage becomes greater compared to this. This process will be keep on continuing. This is how uh, the timing diagram is obtained or delay is obtained. So you can see that this charging, discharging, that will give you a time delay, that is T on. Okay, charge. This is charging and discharging. So that will create your square wave at the output side. Logic 1, logic 0. So that is the delay based upon the capacitor value. You can increase this with T on can be increased further, or by using a smaller capacitance it can be decreased also. So that decides the time delay or a timing circuit is obtained like this. Even the clock signals can be generated like this. By properly designing the capacitor value, we can do this. So after this, we have modes of operation: monostable and astable. So monostable means it will be having one stable state. Astable means none of the states are stable. So next is monostable and monostable multivibrator. So that we'll do it in the next class.